Okay, so today you're going to be doing the lab called Standing Waves in a String, and it is on page 22 in your workbook. So if you could open up your workbook to that page, and then I'll talk you through what it is you'll be doing today. All right, before we get started, just want to give you kind of an overview here. What you're going to be calculating is the frequency of the standing wave. So we're going to be using our standing wave frequency equation that we've been using in this chapter 21. So the frequency of the standing wave, lowercase f, n over 2l, uppercase L, square root of fl over m. So we're going to be collecting data on the tension in the string, which is the uppercase F. Now, as we saw in the demonstration in the class a few days ago, there is a difference between, and often there is, doesn't have to be, but there often is a difference between the uppercase L and the lowercase l. The uppercase L is the actual length of the vibrating string between the wave generator and the pulley on the other end. Now, the lowercase l and the lowercase m are characteristics of the string. In fact, you remember in the textbook, the original form of the equation had this under the square root sign, mass over length. That's the linear density of the string. In other words, for a given length of the string, what's the mass? So we can take any piece off that spool of string, measure its length, measure its mass, and we can get that linear density. So here's the same information that we used in the demonstration in class. So I cut off a piece off the spool that was 200 centimeters long, so that's your lowercase l, and on the scale it had a mass of 3/10 of a gram. I had to get a piece this big just to get a reasonable mass, because it's a very tiny, thin, lightweight string. Now, before you end up using that information in this frequency equation, remember that you have to convert the 200 centimeters to meters and the 3/10 of a gram into kilograms. All right, let's talk through this worksheet now. So at the top of your worksheet, the lowercase m is this mass, again the 3/10 of a gram, and the length of the string, again in this case, this is the lowercase l, which I gave you as 200 centimeters, and there's a place for you to do the conversion to kilograms and meters. All right. Now, one note here, each column on the form represents the number of loops in a standing wave. So you have a 6-loop standing wave, 5, 4, 3, 2, 1. This is another one of those labs where each group won't have time to collect all the data for all the different kinds of standing waves. So each group will come up to the apparatus and create a standing wave, collect data, and then that data will be shared amongst the whole group. So what we're not going to try is the 6-loop standing wave. It's very difficult to do, and we're just going to skip that. The 5-loop standing wave might also be very difficult. You should be able to get the first 4. Now I think if everybody's here today in lab, we should have 5 groups of 2 people each. So we'll have a go at 5 different ones. Now what we're going to start is we'll start the first group that gives it a try. We'll do the 1-loop standing wave. That's the easier one to create, and then working backwards from there might be a good method. So what you're going to be collecting is, on the first line is the length of the vibrating string. That's the uppercase L in your equation. So what you're going to be doing, the very first group will measure the distance from where the string ties into the wave generator over to the top of the pulley, and that will be your uppercase L, and it will be the same in every case, because we're not going to change that length as we go from one group to the next. Then the other data you're going to collect is the mass suspended from the string. Well, why is it mass suspended from the string and not force in newtons? Because all of these weights we're going to hang from the string, as we did in the demonstration, are marked in mass, in grams. So once you, for instance, once the first group creates a one-loop standing wave, then you'll have that data, which was how much mass it took to create that standing wave. And then you'll write that in under in the row for mass, but then you have to do a conversion to get the kilograms into newtons. And that, once you convert the mass into newtons, that's the capital F term, that's the force term that is in the equation. And then the last row is your actual calculation. Then you'll actually calculate frequency, and you'll calculate frequency for each one of these standing waves. Now, how do you know that you're at the right mass? Well, just like we did in the demonstration in class, that what you'll do is you'll try to create for instance, the first group will create a one-loop standing wave, and they can adjust the mass on the string so that the amplitude is the highest achievable. Okay, so you can get a one-loop standing wave which has a really small amplitude and is barely noticeable, but we're looking for one that is a little more substantial. Okay. Now you'll also know that our time in class is very limited, so, and here I am using up your time talking, but so I would not agonize over these standing waves. Each group should not take more than about 5 minutes or so to create the standing wave and get it adjusted to kind of the best amplitude possible. So I would start off with the one loop, 2, 3, 4. Now when you get to 5, again, I wouldn't spend too much time on that. You could give it a try, but if it really isn't working out, then you could just cut your losses and just go with the 4 standing waves. And then also there are questions to answer at the bottom. All right, so let's go over now and take a look at the setup of the equipment. Okay, so we're looking at the back of room 15. I'll have all the equipment you need set up on the workbench at the back of the room. And what I would recommend is that you go ahead and set up for the standing waves at the table here at the back of the room. Set up at the back of the table. It gives a good place to clamp the pulley and the wave generator. Okay. So here's the ingredients. So we have the wave generator right here, and set right kind of on the end of the table like this. Now it'll move around, so there's a C clamp, and this clamp will go just like this to clamp down the generator, just so it doesn't move around. And the string is already attached to the end of the generator. Then you'll need power, so the cable can just snake around, and there's a power strip right here, and you can just plug it in. Now the wave generator itself does not have an on-off switch. Hard to believe, but it doesn't. So the way that you'll turn the generator on and off is just use the switch that's on the power strip right here. Okay. All right, and then we've got a couple of meter sticks And the meter sticks are going to be used to measure the length of the string from where the string connects into the wave generator and then all the way down to the end. So at the end we'll have a pulley and the string will go over the pulley. Alright, so here's the pulley just clamped onto the table, and then you can see the string from the wave generator just goes right over over the top of the pulley. So when you measure the capital L, the length of the vibrating string, it just goes from the other end where the string ties into the wave generator and then just over to where the string goes over the top of the pulley right here. And that'll be your length in centimeters, and then you'll have to convert that to meters. All right, and then we have a number of masses that you're going to hang on the string on the loop down at the bottom. Now, for the first standing wave that you'll try, the one loop standing wave, as you remember from the demo the other day, it takes a lot. So you're probably going to be on the order of 2,000 grams or around 2 kilograms. And then once you get that much on there, then you just have to adjust from there using the smaller ones. Now, one thing you can do, here's a trick that you also can do as well. So here's a mass. Let's say you had this mass on the string and you weren't really sure if it was the best, it was giving you the best standing wave. Then what you can do is put your hand underneath the weight and just push up a little bit, just very, very gently. And if the standing wave gets better when you push up a little bit, that means there's too much weight on the string. The other thing you can do is just very gently with your hand pull down as gently as you can. And when you do that, if the amplitude of the standing wave gets bigger, that means you don't have quite enough on there. So you can play around with it that way without actually putting any weights on. Okay, another comment, just for safety. We've never had this happen, but one of these days I suppose the string is going to break. So when you're hanging the weights on the string, I would stand to one side of the pulley like this, either side of the pulley. I wouldn't stand like right here, right behind the pulley, because if it breaks then it's going to come right at you. So just stand off to the side. Especially be cautious when you're doing the one loop standing wave, because you have a lot of masses that you're hanging on there. So just stand back while you're doing that. All right, I just finished trying this for myself. So what we're going to do is, let's not even attempt the 5-loop standing wave. It gets very frustrating, and the amount of mass on the string is so small. It's very, very touchy. So you should be able to get a 1, a 2, and a 3-loop standing wave. You can give 4 a try and see if you can get that. Now, to give you an idea of where to look, just so you're not too frustrated by this, here's some guidance for you. The length of string that I used, the vibrating string, was 176 centimeters. So if you set it up on the back table the way I showed, it'll be something like that. But make sure you use the meter sticks to verify that. Now, for a 1-loop standing wave, you can look at somewhere around 2,100 grams. So it's going to be a lot on there. So that might be a starting point, and you can adjust it either way. The 2-loop standing wave is around 600 grams, and again, you could put 600 on and then adjust it up or down a little bit to get a good standing wave. 3 is very touchy. I ended up with about 260, so you could start with maybe 250 and then maybe adjust up or down. And then 4 is going to be pretty small. 4 will be 1/4 of 600. So in theory, it should be around 150, but you can try and see what you get. So anyway, good luck, and you can hand these labs in probably on Tuesday, but make sure if you have questions along the way, you can either email me questions or you can ask me the next time you see me in class, and I'd be happy to answer any questions you have. All right, and one more comment. I don't know if I mentioned this yet, but anyway, here are your groups for today. Now, if everybody's not here, you'll have to make some adjustments. So, Cassandra and Allie as a group, Nicole and Cassie, Michaela and Jenna, Emily and Alicia, and finally Courtney and Lindsay. So those will be the 5 groups, and as before, I'll just want one lab sheet turned in per group.